Yes. Okay, now it's recording. So last time we were discussing about the basic things related to the computer. So what is a computer and what is an output device, input device. So those things we were discussing at that time. And today we are going to discuss about computer memory, right? Okay. So I think you all can hear me, right? So no problems. If you are having any troubles, then send me a message. So otherwise, after the session, I have no way to do anything for that. Okay, now I'm going to share my screen. Can you see my screen? Can you see?
Not yet, sir.
Okay. Wait, I will share with sound. Now, how about? I think now you can, right? Now you
Yeah,
can
sir.
see. Okay, computer storage. So here, the mainly we have two types of storage. There are two kinds of storage devices that are commonly used. The first one is primary storage, and the second one is secondary storage. So we called the primary storage as internal storage, and the secondary storage we can call it as external storage. Here, so the storage capacity of a computer is measured in terms of bytes. Here you can see units and its symbols and the equivalent bits, right? So here you can see bytes, and then the symbol is B, right? So that is the basic unit, and so it is equivalent to 8 bits, right? So likewise you can see this chart, right? So then kilobyte, the symbol is KB, and 1024 bytes, right? So then megabyte, gigabyte, terabyte, petabyte, likewise we have this kind of memory hierarchy. Then, so 1 byte includes a total of 8 individual units called as bits, right? So uh, 1 bit can store either 0 or 1, right? So 1 bit can store either 0 or 1. And the table gives the storage capacities, right? So you need to refer this storage capacity table, and then you can find the respective bytes, kilobytes, and megabytes, how they are equivalent to different types of units, right? Then internal storage, and one more message, what's that? Okay. So internal storage, and also called as the main memory or primary storage. So it stores programs and data which are currently needed by the CPU. And RAM and ROM are used as the main memory of the computer. So mainly two types of computer memory, right? So here you can see RAM, that means random access memory, and the ROM, that is the second one. So that is read only memory. So these are the ROM chips. You can see different types of ROM chips available, right? So we have ROM, PROM, EPROM, EEPROM, and different types of ROMs, right? So If you like to learn more about these ROM types, then you can Google and you can find more information about these ROMs, because EPROM and EEPROM, the difference is some ROMs we can electronically erasable, and some kind of ROMs we cannot electronically erasable, right? So that is why we called as EPROM and EEPROM. And this is the RAM, right? So this is a RAM card, you know. Here we have different types of RAM cards with different data rates like DDR1, 2, 3, likewise, right? And now we are having DDR4 also. Okay, so then RAM is used to receive the commands and data from the input units, right? And then store the information already to be sent to the output units, right? So they store the information already, the information ready to be sent to the output units, because after a particular operation, then the output needs to be displayed. So then such kind of information can be stored inside the RAM, and then store the currently running programs, right? So for an example, now I have opened this Chrome web browser, right? So in order to run this web browser, right? So if I suppose I'm going to Google, and then we have different types of websites here. So I'm going to log in to learn, right? So then again, I would like to go for another website. Let's see this one, hit add.lk. Now, right, then now I'll show you something here, right? So I'm going to click on these three little dots, and then I'll go to the history, right? History. I'm going to open the history, right? So you can see now, so which kind of information you can see? You can see all the previously opened URLs, right? So these kind of information are stored inside the RAM card when I open this program, right? So when I open this program, my computer loads these information to the RAM card, right? So that is the meaning of the they store currently running programs, right? They are going to store currently running programs. So that is how they store currently running programs, right? So that's why I have shown you that one. Then store the data required for the currently running programs. Yes. Then store the intermediate data generated by the currently running programs. Sometimes there may be some intermediate result, right? So suppose for an example, if I need to do a complex calculation, and meantime, if I divide my problem into sub problems, then I can get uh, sub problem solutions, right? So I have a very complex problem, and at the time I open that complex problem, I have no way to solve that problem at once. Then what should I do? I need to decompose. That means I need to divide that complex problem into sub problems, and then solve those sub problems. And then I need to store those intermediate results inside the memory. And then finally, I sum up all the intermediate result, and then I can get the solution to the particular complex problem, right? So we have this kind of problems. So that is how RAM performs their operations. So it stores intermediate result of a particular program or particular operation. So store the intermediate data generated by the currently running programs, right? Then random access memory. So here the user can access data in RAM randomly, right? So randomly we can access, and RAM can be erased or written over by the computer program or user, right? Then, so how user can do that? So now here, I'll show you now here. So this is my uh, history of my web browser, right? So here, when I open another new tab, and if I go to a particular website, right? So then what happens? Then it will be here, right? youtube.com, right? So that is how user can uh, override the memory of a RAM card, right? So I can add some information to that. So because I clicked on that YouTube web URL, then it has been added to my history, and then I have loaded this Chrome application inside my computer. Then all the data which is related to the Chrome, so it is available inside the RAM, right? Okay, now, so then amount of RAM, the amount of RAM has increased, right? So we can see actually higher number of memory capacities if we consider the RAM cards, right? So if you consider the mobile phone RAM cards, most of the time Samsung, so they have higher RAM capacities like 8 GB, 16 GB likewise, right? So in computers also the same thing. So here in computers they have now actually it's really difficult to find 4 GB computer with a 4 GB RAM card, right? So most of the time they are 16 GB, 32 GB. Likewise, we have bigger RAM cards, right? And if you compare this philosophy with Apple products, and they are not going to increase that RAM capacity. Why? What is the reason for that? Tell me. So they are not going to increase the RAM capacity like other companies like Samsung or any other mobile phone manufacturers like Micromax, and I don't know the rest of the names, HTC and Google. We have different mobile phone manufacturers, and but Apple are not going to increase their RAM like other companies. Why? What is the reason for that? If you have an answer, then you can tell, right? So then that would be really good, right? So you find that one, right? So you Google and you find, and then next day I'll ask, right? Okay, then so these memory chips are fastest but most expensive, right? So the RAM cards are volatile, right? So the volatile. Then uh, if I consider read-only memory, that means ROM. So ROM stand for read-only memory, right? Read-only memory. So here, the information is pre-recorded into a ROM chip at the manufacturing time. For an example, the BIOS chip of your computer. So they have written the program that is required to run your computer. That means when you press your power button of your computer, maybe a laptop, maybe a desktop, right? So whatever the machine you are using, no problem. So both are having ROM chips, and those ROM chips contains pre-recorded program, and that program works according to the instruction given on that chip, right? So that is required for when you are going to turn on your computer, that program is getting executed, right? So that program checks whether you have plugged your mouse, keyboard, and then the heat of the processor, and you have plugged your RAM cards and everything they check, right? So that program can check everything. So that is uh, the ROM program, right? So inside the ROM chip, you can see that program, and we call that program as BIOS program, right? Then once data has been written into the ROM chip, it cannot be erased, but you can read it. We have no way to erase that program, right? So that is a read only program, right? We have no way to erase that one. And then when we switch off the computer, the content of the ROM are not erased, and but remains stored permanently. So in ROM chip, even if we turned off our computer, the program is still there. No problem, no power problem, right? So that means non-volatile, right? Then actually ROM stores critical programs such as programs that boot the computer. So I told you the BIOS program, right? So and ROM is non-volatile memory, right? So these things are really important. Maybe MCQs, right? Then, and before moving to that, if you are having any questions about RAM and ROM, so when the power goes, right? So we have no anything which we have recorded inside the RAM card, right? So that is why we say it is volatile, right? And but when you consider a ROM chip, so even after the power failure or whatever the after if we unplugged our computer from the power, or when we turned off our computer, the recorded program or the stored program is still available inside the ROM chip, and we call this as a non-volatile, right? Right? Any problems? Okay. Now, external storage, also called as secondary storage, right? So, and it does not depend on constant flow of electricity. That means non-volatile, right? It does not depend on constant flow of electricity. In our computer hard disk, if we store something inside that hard disk, even after when we turned off our computer, the stored information is still there. No problem. We can access that information anytime, right? So, and it has large uh, space capacity and reliability and convenience and economy, because we can but not Sri Lanka. I'm not going to consider Sri Lanka here, right? So sometimes there may be these statements are not true if you consider Sri Lanka, but if you consider the context as world, so then these external storage devices are really economical devices, and they are not really costly devices, right? So it contains large space capacity, and it's reliable, and it's convenience, and it's more economical, right? So then, and we use to store programs and data for future use, right? So we can store a particular program or particular information, and then we can use those data in future days, right? Then magnetic disk. So magnetic disk are thin circular plastic plates on which some magnetic material is coated. So magnetic disks come in various sizes and materials. So they use the properties of magnetism to store the data on the magnetic surface, right? A disk pack normally consists of such disk mounted onto a central shaft, right? Just if you consider the hard disk. I'll show you, right? After this slide, I'll show you uh, the mechanism of the hard disk, right? So then the central shaft rotates at speed of about 7,200 RPM, right? So that is the RPM value. The general value is 7,200, right? So we have a plastic disc, and on top of that disc, we have plated and we have coated some magnetic material, right? And then we can use that magnetic change to store some information inside that plastic plate, right? So in a disk plate, information is stored on both surfaces, right? So we can use both the surfaces to store the information. I will show you how it happens also. And the surface is further divided into number of invisible parts, right? So I will show you those parts, just like sectors, tracks, and the blocks, and we have different types of terminology to divide those areas on top of the hard disk, right? So I'll show you those things here. So the magnetic disk, and two types of magnetic disk, right? So the first thing is hard disk, and the second thing is floppy disk. But nowadays we are not going to use this kind of floppy disk, right? So actually now we are removing the hard disk also, because now we are moving with solid state hard disk, SSDs, right? So nowadays actually we are, when we are going to buy a new computer, actually we are not going to use this kind of mechanical hard disk. The reason for that, the performance, right? So when we are using this kind of mechanical devices inside the computer, then it takes some time to read information, right? So that's why when you, if you are having a computer with SSD, and if you are having another computer with a mechanical hard disk, then you can see the performance difference. And almost all the modern operating systems are developed based on the SSDs, not the hard disk. And I think Microsoft also uh, going to remove the mechanical hard disk by removing the support for that by using their operating systems. I think after the Windows 11, they are also going to move forward with SSDs, and then the future computers will come with SSDs and not the mechanical hard disk. Right. Then we need to talk about little bit floppy disk, and then I will show you how the hard disk works, right? So then floppy disk. Here, the floppy disk contains a single flat piece of circular plate coated with metal oxide and enclosed in a plastic cover. You have seen sometimes this kind of floppy disk, right? So, and floppy disks are small and portable, right? So here you can see the anatomy of floppy disk or the diskette. So here, this is the right product square, and this is the plastic cover, and this is the label, and this is the metal hub. You can see the center point, and this is the diskette, right? So this circle, and these are the lines, right? So that is how you can see the anatomy of diskette. And actually nowadays we are not going to use this kind of thing, right? But keep that in mind. This is also a magnetic disk type, right? Mainly we have two types of magnetic disk. So what are those? The first thing is hard disk, and nowadays also we are using, still we are using, and the floppy disk, actually we are not going to use those things. And I think they have discontinued this kind of floppy disk from 2000, from 2000. I think I even when I was a student, also I didn't use this kind of floppy disk, right? So then think about that your level, right? So actually we are not going to use this kind of floppy disk, but remember this is also a magnetic disk type. Okay, so then tell me if you are having any questions. Okay, now I'm going to show you a particular video related to a computer hard disk, and give me a time, right? So now I'm going to stop share. Now I'll show you that one. So you can see this video, right? So this is the 3D model of the hard disk. Can you see my screen? Can you see? Tell me.
Yes, sir. Yes, sir.
Okay.
Yes, sir, we can see.
Okay, now listen.
For complete data recovery training, just log on to www.dataempires.com. Here, You can learn all the course for lifetime in
So did you see the how the hard disk works? So I'll show you another video.
I'm Joanne Larson. I work at Seagate in a design center.
So this video has been recorded inside the Seagate factory, right? So you know the Seagate is a hard disk brand, and this is the actual design of the hard
I
disk.
have two drives here just to illustrate a couple of form factors that we design. This is an example of a 2.5-inch drive, as we call it, which would be used, for example, in a notebook computer. This is what we call a 3.5-inch form factor. A hard disk drive is so named because the heart of the matter is where the data is stored, which is on.
So this is the magnetic disk, right? So we can store information both the sides, right? So this side and the other side, right?
These disks, and the data is stored magnetically as ones and zeros.
So this is the hard disk head, and this is an actuator arm, right? So this arm works according to the instruction given by the computer processor, right? Actually, this head does not crack the drive, right? So very small space between this actuator arm and the hard disk, right? So that means this is the platter. We call this as platter. So there's a very small space, that means very small gap between this hard disk actuator arm and the disk platter, right? So we call this as cushion air, right? So then when this works, they charge this electrical head, and either negatively or positively, and we can store the information according to the this magnetic change, right? So here you can see we can magnetize this actuator arm, the head of the actuator arm. According to that, we can write information inside this disk, right?
Or as magnetic bits that are oriented north or south. It is read or written, as we say, by very small transducer.
Right here you can see we have several actuator arms. That means in this hard disk we have 1, 2, 3, 4, 5 disks, right? So we can have parallel 5 disks inside this hard disk because we have 1, 2, 3, 4, 5, 6 arms we are having, right? So then we can use 5 platters. That means 5 magnetic disk we can use with this set of arms.
Transducers on heads. So this little roughly triangular shaped feature can be thought of as the size of a bit. When we write, and this is the write pole, the flux is essentially focused through that pole. The corresponding area on the media below it is magnetized.
Right, so now you can see what happens. So this is a microscopic image, and so this is how this computer head, that means the head of this arm, writes information to the platter, right? So microscopic, and write and read.
The head is out flying on a suspension at the end of.
Now this is the head, right? So this is the actuator arm, and this is the head, and we can charge this head either positively or negatively by using electrical charge, right? So those instructions coming to this head with the help of the computer processor, and according to the the processed instructions, and then they can charge this one either negatively or positively, and then those charges transmit to the this electrical as electrical signals inside to the platter, right?
An arm, this is an arm,
Right. So
which
this
is
arm.
part of what we call the head stack assembly. The arms move back and forth across the stroke and read the various tracks that are laid out on the disc. These tracks are so narrow that we fit about 300,000 of them in an inch of radius. The arms, the HSA pivot is actuated in this case, and I think this is kind of fun, magnetically. As we know, electricity and magnetism exist together, and when a current is run through a wire, there is a corresponding orthogonal magnetic field. So,
Right. So this concept, you know, in your in if you have done physics, then you know. So when the current flows inside this wire, you can see this kind of electrical fields, and the same concept they are using to move the actuator of the hard disk, right? So
how we are using that here is that there is a coil, which is, it's actually hidden under this magnet. Under this plate, there's a magnet. And below the magnet is a coil. The driving force
so this is
of
the
the
coil,
current,
right?
or conversely,
So
the
by using this
magnetism
coil,
forces
by using that coil, we can move that actuator arm with the help of the physics, right? So you know the electrical charge, the electrical charge we can use to move this
the
one.
back end of the coil to move in one direction or the other. Right here we see the motor that spins the media.
So that is how they design this kind of hard disk, right?
When the drive is powered off, the heads are resting on this ramp. The arm swings off so that the head.
So what happens when you turn off your computer, then head comes to this ramp and they store leisurely inside this ramp, right? So when the power on your computer, then this actuator arm again goes to the goes towards the hard disk, right? So when you turned off, it is here, right?
Are preserved and they're not touching the media or anything. If I want to write or I want to read, in other words, if I want to record a picture or if I want to bring out a picture file, the arms swing out over the disk and the heads are flying over the tracks, as we call them. So it goes to a very specific radius and the drive will be given an address to go. Let's pretend that was the radius, that was the track that contains the picture or part of the picture. That is the file that we said, please show me this picture. The data is recorded in magnetic domains that are very small surface area on the disk.
Actually, sometimes you may think this computer hard disk recorded data as ones and zeros, right? So in our world, naturally, actually, we have no way to write ones and zeros inside the computer hard disk. The only thing is we are going to store the electrical charge difference by using magnetic mechanism, right? So either positive or negative, right? So in general, we call it as ones and zeros.
The transducer on the head senses for that domain the direction of the magnetism and whether it is a 1 or a 0, and that's a bit. The head takes off.
So those are the things I need to mention with respect to the hard disk, right? So I think now you have an idea about how the hard disk works, isn't it? Is it okay? Tell me, and you all are silent, but I don't know why. So you can speak, you can ask any questions. Okay. So then what are the questions they are asking? Okay, no questions, right? Now I'm going to move forward with the second part of the memory, right? Second part, this one. So now we are going to talk about hard disk a little bit more, and we need to talk about some other important information about this computer hard disk here, right? So the most common physical device for storing files is hard disk. You know, in every computer now we are having hard disk. The hard disk typically contains several rotating disk plates. I told you that one, and we call those disk plates as platters, right? So the surface of the plates are covered by metal oxide, and the electromagnetic recording heads performs read and write operation on the disk. So there is one head for each surface. I told you there are multiple heads which they have attached to the actuator arm, and all the heads are moving together, right? So all the heads are moving together, not the separate heads. All the heads are moving together, and there is one head for each surface. Yes, I told you that one, and the rotating speed is 7,200 rpm. That is the general speed of the rotation of a hard disk. And modern disk typically hold 260 GB to 1000 GB. That is 1 TB, right? The surface of the plates is organized as number of concrete tracks. So each track is divided into sectors, and set of matched tracks are called as cylinders. So now here, so these are the different types of hard disk, right? So you know SATA and SCSI. USB hard disk is also available, and IDE hard disk, very rare nowadays. I will show you hard disk, IDE one, right? IDE hard disk. So you can see here. So we have lengthy pins here. We have very wide pin set. So we need to connect our hard disk IDE cable to this set of pins, and then we need to put the rest of that means the other side of the cable into the computer motherboard, right? So this is a IDE hard disk, and if we consider SATA hard disk, I will show you SATA one. So here, this is a SATA hard disk. So here you can see this one, right? So the bottom one is IDE, the top one is SATA. Here you can see very small pin set here. So we can connect our SATA cable to here, and then we can also give the power as the SATA power. So, and also we can give the normal power if we need, but it's better to give SATA power, right? So here, this is the example. So here you can see this is the place which we are going to plug our SATA cable, and I will show you a SATA cable also, and this is the SATA power, right? So that means we have separate way to give power to hard disk by using SATA power. I'll show you all the things. So the first, I think I'll show you SATA cable. SATA cable. So this is a SATA cable. So this cable. So we can plug this port into these pins, right? So we can connect to that place, and then if we consider SATA power, you can see there is a power cable with SATA connection here. Where's that? So this one. Here you can see this is the normal power, right? So inside the power supply, almost all the time we are having normal power sockets, right? So, but if we are having a SATA hard disk, then we can convert that power to SATA power by using this cable, right? So I'll show you another example for power supply. So this is a power supply. This is a computer power supply, and it contains this kind of wires, right? So here you can see we have this kind of wires with pins. So then if we need to connect these one of these power socket to our SATA hard disk, so what we need to do here, we need to convert that power using SATA power cable. We have this kind of cables most of the time. With the newer power supplies, we can get this kind of power converters, and then we can convert that power, and then we can give power to our SATA hard disk by using this kind of cables. Right, so that is how you need to give power to the SATA hard disk. Right, so you know in the USB hard disk also they are, and IDE I show you. Then what about SCSI? SCSI. So SCSI also a particular interface for hard disk connections, right? So a small computer system interface, and so that is how it connects to a hard disk, right? So that is a separate thing, and most of the time we are using nowadays USB hard drives and SATA hard drives, and in future now we are going to remove this SATA one also, then we are dealing only with SSDs. So here I have shown you this image before also, because you saw inside the video. So these are the actuator arms, and these are the headers or the heads of the arm, and these are the platters, right? So here, so accessing the data on a hard disk, you can see here. So we call this as a disk cylinder. That means here you can see different levels, right? So here I think you can see. So if we choose this area, so then we called as, if you can go to the bottom like that, that means, or if you consider this small area, and if you consider the bottom level, then we call this as disk cylinder, right? So as a cylinder, and this is the circuit board, and this is the read write head, and this is the access mechanism that I told you how it works, right? So here, this is the disk cylinder, you can see clearly here, right? So this is a sector, and this is a track. You can see these are the tracks.
No, we can't see the screen.
Yes,
What happens
can't.
now? Is it okay? Can you see?
Not yet.
Not yet, sir.
What's the problem? Again, I'm going to share now. Oh, so many messages there.
Okay.
Now,
Okay.
okay, sir.
Okay. So here, so I have shown you this kind of image inside the video also. So then I'm not going to discuss this one. So I was discussing this image, right? So here you can see, I need to zoom in because otherwise can't see here. So if you consider that magnetic disk, and if you divide that disk like this, you can see this is a track. This area, this entire area, we call it as track, right? And this is a sector. So this is a sector, and also here also you can see this is a track. This is a track, and so this is the central shaft. So according to the shaft, that disk can rotate, right? So we don't need to worry about the shaft. So the important thing is track and sector. And here you can see if we align those set of hard disk platters together, so we call this as a cylinder, right? So this is a disk cylinder, right? So now you know this is a sector, right? So here also you can see this is a sector and this is a track. And if you consider all these four platters together, and we call this as a cylinder, right? Is it okay? Any problems? So then magnetic tape. So I'm going to discuss about magnetic tape. So here, and these actually nowadays these kind of things we are not going to use, but as according to the completion, because you need some kind of knowledge about the computer, the basic things. So I'll cover this one also. Here the magnetic tape, so the popular with mainframe computers. So then the speed of access is quite slow, and used for backups of large amount of data, and maybe 200 GB and greater, right? So magnetic tape, not the disk, right? And then zip drives, and can install zip drives into a computer, and then can insert zip disk into the drive, right? So it's like a CD drive. You know, we can store the CD drive inside our computer, and then we can put CDs. So exactly the same way that you can place the diskette drive, right? So this is similar to the diskette drive, and great for backing up data. That means we can put another copy of the data which we are still using, right, for safety purpose. If a particular problem happens, and when our original data goes, then we can use the already backup data. And slower than normal hard disk, and it contains 100 to 250 megabytes, right? So that is the capacity. Then optical disk. So the optical disk is a random access removable disk on which data is written and read through a laser beam. So here we are using a laser beam, and we can write the data by using the laser beam, and then we can read the data by using the laser beam, right? So the optical disk consists of rotating disk, right? So, and which is coated with a highly reflective material. You know, you have seen some CDs and DVDs, and they have coated some reflected materials with some reflected materials. So data recording on the disk is done by focusing a laser beam on the surface of the spinning disk, which stores data as microscopic light and dark spots on the disk surface. I'll show you that one also. And the dark spots are called pits, right? And lighter, or the non-spitted surfaces are of the disk are called lands, right? So we have lands and pits, right? So the disk spots are called at pits, right? So, and we have what happens? What happens? I can see a red line here. Okay, no problem. So maybe someone is using their mobile phone, and sometimes these kind of things happens if someone using a mobile phone and using the Zoom, right? So anyway, so I talked about pits and lands. So the dark spots are called as pits, right? So then lighter non-pitted surface area of the disk are called lands. So lands represent a binary 1 and pits represent a binary 0, right? So even if we are using a optical disc, the same philosophy we are using, because the computers are digital devices and they only can understand ones and zeros. Even if we are going to write something onto a hard disk, then also we are using ones and zeros. And the here also the same mechanism inside the optical disc also we are writing information by using ones and zeros. So the purpose of recording data, the process of recording data onto a optical disc are called burning, right? So if you have used uh, Nero software, right? So most of the time earlier we used that one. We can burn a particular information to a CD or DVD, maybe a movie, maybe a data file or anything, right? So we called as the process of recording data onto a optical disc are called as burning, right? Then so there are different types of optical disc, right? So here we use CD and DVD, right? So CD and DVD. CD means the compact disc, right? So the CD-ROM stand for compact disc read only memory, right? CD-ROM stand for compact disc read only memory, right? So it is read only the optical storage medium capable of holding up to 682 MB of data. That means initially actually we called as 700 MB, right? So that is the storage capacity, right? So sometimes there may be some CDs we can write up to 730 megabytes, right? So actually, I think nowadays it's really difficult to find even not a CD. It's difficult to find a DVD also, right? So because nowadays we are not going to use this kind of optical disc, right? So the previously we eliminate CDs and we came to the DVD, and nowadays we are not going to use DVD also, right? So these things are now we are eliminating. So accessing of data from CD-ROM is quite this faster than the floppy disk, but slower than the hard disk. To read a CD-ROM, a device called CD-ROM drive is needed. CD-ROM drive is needed. You have seen these things earlier, right? So this is the CD-ROM drive, and this is the indicator light, and this is the CD tray. We need to put our CD, right? So this is the CD or the compact disc, and we put that disk into this drive and this tray into this tray, and then we need to close this tray. So then reading process will be started, right? So in previously actually, if you have seen LG, Panasonic CD drives, it contains uh, earphone jack also, right? So and the volume control option is also there, but the newer ones we cannot see these kind of things like the new CD-ROMs like the Samsung and such kind of things. They have developed this kind of CD-ROMs very recently, and those kind of devices actually we can't see those two options. These two options only available on very old CD-ROMs, CD-ROM drives, right? Then DVD, right? So they stand for digital versatile disk, right? So it's an optical disk technology with 4.7 GB storage capacity. It's initially, right? So, but actually, typically it contains, it can write up to 4.7 gigabytes. Actually, we have 16 gigabyte DVDs, right? Because we can write both the sides, and those CDs are very costly and very rare, right? So the DVD can be a single or double sided and can have two layers on each side. So DVD can be single or double sided. That means we can write both the sides. So most of the time we can write data on a single side, but we have some of the disk with double side availability, and can have two layers on each side. So if that particular disk contains two layers, then we can write uh, actually we can double the capacity of each side. That means 4.7 into 2, right? So 4.7 into 2, again on the next side also 4.7 into 2, 4.7 into 2. So one side, then we can write up to 9.4 GB, and I'm going to multiply that one 2. So, and then we have 18.8. So the maximum capacity of DVD drive, if you can, if that particular disk support for double side and double layer, then the maximum capacity is 18.8 GB, right? So the double side two layer DVs will hold up to 7 GB of video, audio, and other information. If the actual size is 18.8, actually we can use up to 17 GB or something like that. So DVD technology uses a red laser, right? So they are using a red laser, right? So now I will show you how the DVD and CD works. So I'll show you pitch and lands of the CD, the first thing, right? So here, consider this image, right? So this is a very, very tiny, right? So actually, if you, this is the internal mechanism. So this is the plastic disc, and here you can see pit and land, right? So pit and land. So then we can generate some electrical difference by using these pits and lands, right? So if you can see it within an electropic microscope, so now it would be like this, right? So you can see how it happens, right? So if you zoom in a particular surface of a disk area, so it would be like this. So this is how we store data. So how we can generate these pits and lands? By burning a particular area by using a laser, right? So we use a particular laser to burn this disk surface. Then we can use this one as a ones and zeros, and then by using this mechanism we can store data inside the optical disc. The same mechanism we used in DVD also. The difference is sometimes there may be some DVDs we can do this operation two times for a single side. That means it contains two layers. We can burn up to two layers, right? So it contains two layers, then we can burn each and every layer, and then we can store more data. Right now, portable storage devices. So, portable storage devices. Portable storage device means it's a small hard drive designed to hold any kind of digital data, right? So this is slightly different from portable media player, which stores and plays music and movies. So like Apple iPod, and some are fixed size hard drives, and it contains up to 256 GB, 320 GB, 500 GB, and 1 TB also, right? You have different uh, capacity sizes, right? So now SSD. Now you have seen these things. I'm not going to discuss more detail about these portable storage devices. Then SSD, solid state hard disk. So a solid state drive is a data storage device that use solid state memory to store persistent data, right? So actually inside this solid state hard disk, we are not going to use any mechanical component. That is the major advantage, because if we are not going to use mechanical equipment inside this hard disk, then we don't need to move a particular head here and there to find the information. So it always leads to have some latency, but because of this solid state technology, we have no any mechanical movement inside the hard disk. Therefore we have good performance if we are using a SSD. And there may be some disadvantages also while we are using SSDs. And but if we consider overall, so the solid state hard disk are really good. So here it is a flash based storage device, and it uses same IO interface developed for hard disk drives. And SSD do not have any moving mechanical components, I told you, right? So which distinguish them from traditional magnetic hard disks such as HDDs, hard disk drives, right? So this is a SSD, and you can see, so this is actually very earlier SSD, and nowadays actually this kind of SSDs also we cannot find, right? So one thing, what's that? So is it compulsory to use SSD to a laptop nowadays? Actually, I have to say yes, because most of the time modern operating systems, and I'll advise you, and one real thing, right? I'll tell you, and this is my opinion, right? And actually, when you are going to buy a computer these days, it's better to have more than 4 GB RAM, right? So if you are having a 4 GB RAM, then if you have already bought, then you have nowhere to change it, right? So you can upgrade that one. But if you are going to buy a new computer or new laptop or whatever new device, right? So this is belongs to a computer, right? So it should have at least 8 GB RAM, right? So 6 GB is also okay, but if you are going to upgrade at least up to 8 GB, right? So you can use 4 GB 2 RAM cards. And SSD. So the SSD is also really important, because the most of the time now operating systems are getting complex, and it contains different advanced concepts, right? So then like the old operating systems like Windows XP, Windows 7, up to Windows 7, that is not a problem. You can use your old hard drive, and you can use that one, no problem. But if you consider Windows 10, 11, so then you should use SSD. So otherwise actually really difficult to work, because the performance is really low. because of this mechanical hard disk. And if you are going to pay more than 2 lakhs for a laptop computer, right? Uh, I advise you to buy a MacBook Air, because you can buy, I don't know, the in Sri Lanka, but nowadays, almost all the laptops are 2 lakhs and 2.5 lakhs and likewise, right? So, and another question, I'll answer that one also. Uh, so when you are going to buy, when you are going to spend more than 2 lakhs for a computer, I advise you to buy a MacBook Air, not the Pro version. Pro version is really costly, and you don't need to pay for that. So maybe sometimes 8 lakhs or something like that. And so you can find something used one for 5 lakhs. So those things are really costly. I'm not going to advise to buy those things. But if you are going to spend more than 2 lakhs, right? Maybe 2.5, 2.8, something like that. I advise you to buy MacBook Air. So that is really good, and that is really durable, right? And no performance issue, no any performance issue, no battery issue, nothing, right? So you can use more than 10 years if you can buy a brand new one, and the second hand and the used ones are also there. But when you are going to buy those kind of devices, if those kind of devices are second hand devices or used devices, then you need to pay more attention, right? So then, so that is my advice, because the Windows operating systems are getting slower and slower, and really difficult to work. So if you would like to use Windows, then you can use Windows, no problem. But according to the perspective of the performance, I advise you to switch to the Mac. Right. So the next question, what's the next question? How to improve the 4G signals in the Wi-Fi? Okay, okay. But I didn't, today I didn't buy my, actually, I had a router, but I think it is not in the office. But anyway, I'll tell you. Then, so what's that? Then I need to discuss Jazz drive. So similar to zip drive. Actually, did I talk this one? No, right? So SSD. Yes, similar to a zip drive, but can hold a lot more data, and great for backing up, and slower than normal hard disk, and the storage maybe 2 GB. So any questions? Any questions? Any unclear points? You can ask. Because now I have completed input devices, output devices, computer memory, right? So the MCQs most of the time will come from this section also. Yes, I will send you the PDF. Yes, I will send you, and the last batch also I gave those PDFs, and you can download all the things once you can log into the LMS, right? So before that also I will send you. Okay, then right, my next part, and only 107 students, and last time I think 112. So okay, now we are going to talk about internet, the very interesting topic, right? Yes, up to now I think you cannot access. And is there any session related to the LMS and how you can access that one? Was there any session related to that?
Not yet, sir.
No.
No.
Okay, there will be a session, and then the respected persons tell you how you can use that one, right? So then now also all the
Excuse me,
content available. Yes.
Roshini madam told that we asked to log in by LMS by using that our old link by registration and
Yeah.
after registered by using that old link.
What happens? Did you log into that one?
No, I told to next session
Oh,
LMS to madam asked to log into the that session by using old link.
old link.
Yes, link.
Which old link? The previously
That
I used one.
after ready the link that join we can join to the meeting after registration.
Yeah. I saw that one.
Yeah.
Yes. Okay, and you will be having another session how you can access LMS and how you can deal with LMS, right? So that will be a separate topic, and that is not related to me, and the respective persons will do that one, right? And okay, now we are going to talk about internet nowadays, really hot topic. So these are the objectives of the lesson. So define the internet and some standards related to it, and describe internet services, understand the basic terminology related to the internet, and identify the methods to connect to the internet, and familiarize the web browser, search engine, and web efficiency and effectively, right? So search the web efficiently and effectively, and I will tell you how you can search something on the internet. One more thing. What's that? Is that we want to study for the exams. What's that? Is that we want to study. No. That is inside the video, because I told you the internal structure of the hard disk, and I have shown that one because that is for your knowledge, and I'm not going to ask those internal concept from you, right? So that is only the video, and I have shown you to understand the concept. So all the things coming from the notes, right? Not the videos. Is it okay? Okay. Right. So study well, and then you can pass the exam. And there are students who, actually they are repeating the subject. I don't know why, right? Sometimes we have 5 6 students every time. They are also every day they are sitting for the exam. Don't know the reason, but I expect from your batch you all should pass the exam one time, right? So do not going to repeat the subject. So that is really difficult for us. And in your side also that is difficult, right? You have so many things to do, and still you are doing the first level courses. So that is difficult, and attend to the lectures every day, and attend to the practicals every day, and submit all the assignments, then you can pass the exam, right? And if you are not studied well, then a little bit difficult to pass the exam. You need to do the assignments and everything, right? So that means you need to give the same priority to this subject also, right? So because we have other subjects also, but even if you pass those subjects, you have no way to obtain your degree, because if you cannot pass this exam, right? So sometimes there may be students, they cannot get the degree because of this subject, right? Because this subject is easy, and but if you didn't pay more attention to the subject, not only this subject, any subject, so then you have no way to pass the exam, right? So introduction. So now we are living uh, in the information era, so information has become so vital and day-to-day activities of our lives. So computer has become the main device to manipulate information. So that is because of the ability to process information faster than human. And with the improvement of the networks and with the extension of the network towards the internet, and when the internet became widespread all over the world, any person in any part of the world got the opportunity to communicate with any other person at other part of the world, right? So that is how internet grows, and that is how internet comes to the picture. So you can see this image here. So this is the world, and you can see different computers and different connections between those computers, and we call this as internet. But if I ask you to write what is internet, then your answer should be internet is a network of networks, right? So what is internet? So internet is a network of networks, right? So remember this S, right? Internet is a network of networks, not network of network. That is wrong. Network of networks. Remember this S. Okay, an interconnected system of computer networks, right? So that is an interconnected system. Then it is the largest computer network in the world. There is no such largest network in the world other than internet. So these connections allow the computers to communicate and share information using the same communication protocol called TCP/IP. So the TCP/IP is a protocol. What is the protocol? I think you learned this concept in grade 11. Tell me what is the protocol, and I'm waiting for your answers, and then I can imagine the level of your knowledge. Rules, yes. And others also tell me. You have different answers. Only one answer. So others, you also can answer.
Like some kind of access gate,
Uh, like some kind of.
access gate to the network.
So I didn't get your answer.
It's some kind of gate or access gate to the network or something.
Uh, okay, we'll see. So processing data, different answers. Yes, what you have learned, tell me. Then I can correct you, right? So the original draft to the document. Any other answers?
The official procedure system of rules.
Yes. Special rules for communication. Yeah, that is correct. And okay, so now see. So TCP/IP is a communication protocol. That means set of rules which is used to communicate. The protocol is a set of rules which is used to communicate, right? And I'll show you with examples, and real good examples I'll tell you, right? I'll show you with examples and how these different protocols works and everything. Okay, now uh, what is the internet again? So a computer which is connected to the internet is known as the host. A computer which is connected to the internet is known as the host. So tell me, uh, if you are using, if you are going to access Facebook, Google, whatever website, using your mobile phone, so then is your mobile phone acting as a host? Tell me your answers. Tell me, I'm waiting your answers. Oh, one answer. What's that? Yes, yes, that's correct. Yes. So then, when we are using our mobile phone to access internet, then our mobile devices are acting as a host device, right? Okay, that is correct. You know the concept. So once the computer or computer devices are connected to the each other, they can communicate and share resources with each other. So this is a really good advantage. So once we are connecting to the internet, right? Then we can communicate and share the resources with each other. Now, so these are the definitions about internet, and you read these things. I'm not going to read these things, and in exam also, I'm not going to ask this kind of philosophical definitions, right? But you read, right? So then, what is the internet? So it's a combination of network of computer networks plus telecommunication plus protocols plus users, right? So this is the combination. Now these are the required things for the internet, right? So we need computer, that means we need network of computer networks, then telecommunication, then protocols and the users, right? So this is history. And so the internet was born on 1969. So ARPA, that means Advanced Research Project Agency, within the US Defense Department. So so they are the root cause for the internet, right? So it was the first known as ARPANET, right? After that, it was becoming internet, right? So it started with 4 interconnected computers in 1969 and was known as ARPANET, right? So Advanced Research Project Agency in United States Department of Defense. At this stage, the internet's first computers were at academic and government institutions and were mainly used for accessing files and to send emails, right? So that is how internet has been originated. So in 1979, the ARPANET quickly developed to communication tool, right? So the ARPANET quickly developed into a communication tool. So used for email discussion groups and for exchanging files. And so then 1979, Usenet was born, right? So Usenet is a huge network of discussion groups. So then 1983, so in 1980s, several other similar networks started popping up. So these different networks had trouble communicating with each other because they use different communication methods, right? By the end of the 1983, a standard communication protocol was established and called as TCP/IP, right? So that is how TCP/IP coming into the picture. So all the separate networks started using the protocol and connected to one another. So this became known as the internet, right? So that is how internet has been emerged. Then 1989, Tim Berners-Lee and others at the European Laboratory for Practical Physics developed the World Wide Web and affected to the fastest growing and the most interesting part of the internet. right? So that is the brief history of the internet, how it has been emerged and everything, right? Now, uh, who controls the internet? Actually, is there any answer for that? No one. No one is responsible for controlling the internet, right? So now these are the several internet governing bodies, right? So DARPA. So that means US Defense Advanced Research Project Agency, and handles certain key functions which have been critical for this for its operation. And the other governing body is the Internet Activities Board, IAB, created in 1983 to guide the evolution of the TCP/IP protocol, so it and provide research advice to the internet community. So this is the growth of the internet. You can see in 2006, right? So the internet populations in million, that was 40, and then 2007 it was 42, that means 42 million, and 2009 it was 81 million. Now likewise you can see how it has been grown, right? So the growth of the internet. Now here in up to 2019 you can see 699 million, right? Now more than that, because this is 2022. And so now internet vs world wide web. So if you know, can someone tell me what is the difference, or the what is the major, the actually I can ask it as difference. So tell me what is the difference between internet and world wide web, if you know, right? Tell me, I am waiting for your answers. No answers yet. So tell me, you don't know, right? If you know, you can send me. If you don't know, it's okay, no problem, because you are going to learn those concepts. That's why I told you this is not a general CLC course, and you are going to and learn some basic things, right? So this is basics up to the university level, right? What's that? WW used to connect into the people. Any other answers?
World Wide Web is the pages we see and when we are using the device and when we are in online. But the internet is the network of networks connected to the computers.
So again, I didn't get World Wide Web part, but internet part is okay. What's the World Wide Web part? You told, but I didn't get.
World Wide Web are the pages we see when we are at the device.
Yes.
And we are online.
Okay. Now see, your answers are a little bit closer, but we can see the exact answer, right? So we are having exact answers, and we can see those answers. But before that, it's better to ask from you. So then you are also really interesting about to convey your knowledge to me. So then I can get an idea about you, right? World Wide Web is the topmost service used in the internet. Who's this? Who's this? Prabuddhika, right? Okay. Now your answer is correct, right? 100% correct. That's good. Okay. Now let's see. So internet is World Wide Web. So use these terms interchangeably, but they are different. So they related. They are represent different functions. The internet is a huge system that connects millions of computers together via this network. Then the World Wide Web is one of the ways that information can be transmitted over the internet. Now you know the difference, right? So the World Wide Web is one of the ways that information can be transmitted over the internet. And the difference between internet and World Wide Web, now you know the internet is a network of networks, and if you come to the World Wide Web, so that is the one of the ways that information can be transmitted over the internet. Right. Now other methods of transmitting information over the internet includes email and instant messaging and FTP. FTP, what's that FTP? If you know, tell me what's the meaning of the FTP?
File transfer protocol.
Yes. Have you ever used this protocol? Have you ever used this protocol? One answer. What's that? Yes. For what? So email. So email, we are using another protocol, SMTP, Simple Mails Transfer Protocol. So which type of purpose you are using FTP? If you are using, yeah, tell me. So yes, I know. You know that is the file transfer protocol, and if you have used that one, so which type of purpose you use that one? Download files. That is correct. Tilini, yes. For downloading, uploading. Oh, really important answer. What's that? Who's this? Upload files. Yes. Have you, Tilini, have you ever used this one? Tell me, Tilini. So, have you ever used this one? Really, interesting your answer actually. So, have you ever used this one? No, only download files. Yes. Okay. Then your answers are correct, right? Uh, we can use FTP for uploadings also, right? So if you are going to develop a particular website or a particular web program like Facebook or any other websites, you know, so we have developed, we develop those websites in our personal computers inside the office, right? Maybe sometimes nowadays, because of the work from home, we are developing those websites on our home computers, right? So those web projects we are developing when we are at home. So after developing those websites, we need to put those websites into a particular public place, because for an example, University of Rohana website or Facebook, whatever the website, now you can access publicly. So those websites are developed inside the office, right? After developing that website, we need to put that website into a public place, right? So everyone should be able to access that one. Then we need to use this file transfer protocol to put this whatever the thing we have developed as website into a public server. So for that we use FTP protocol, right? So the application which uses FTP protocol, I will show you, FileZilla. Have you ever heard this name? Have you ever heard this name, FileZilla? No, you don't know. Oh, really? Because you are not the web developers, just only you came to the university, right? Okay, so because in my degree, actually I was a computer science student, and now I'm working as a computer science researcher, and I have published so many research papers. And as a web developer and a software engineer, I have been working with many organizations, and I have developed many web applications, mobile applications, and everything. So now with the academic field in university, and previously I have been working in University of Jawaharlal now here. Okay, so now FileZilla. Here, the FileZilla, I'll show you a interface of that because I have already installed this one. I'll show you a picture. This one, this is better. Can you see this image? Let's try to zoom this one. Oh, no. Now, I think you can see, right? Can you see? Now you can see, right? Tell me. Okay, yes, yes. Right. Here you can see when you are going to upload our website, which we locally developed into a particular web server. Web server means a particular computer that we can access it publicly, right? So that is a public place we can access by using a particular web address, right? So for an example, www.facebook.com. So here, this is our computer site. You can see C drive, and this is a particular directory. That means a set of folders here. So it contains several folders, and inside those folders, you can see different folders and files, right? So because here you can see this is the folder which they have opened, and under that folder you can see these kind of files. So this side is your computer side. This is your computer, and this is the place which we are going to upload our website. Typically this is a server space, right? Server space. In this place we are going to put our website. So whatever the thing we need to do here, so I need to suppose I need to upload this file. I need to click on this file, click and drag, and then I need to uh, release my mouse here. Click, drag, and release mouse here. Then what happens? It will upload my file by using this FTP protocol, right? So that is how FTP protocol is being used in real world. You can see here, right? Here you can see this is the transmission. File transmission is being processed. You can see it is being transferred, right? So this is the real life usage of the FTP protocol. So which kind of thing we can do by using FTP protocol? We can host a particular website to a particular public web server. Is it okay? Right? No problems. Tell me. Actually, this is not a course. Actually, this is just a discussion, and I share the knowledge with you, right? Just not a basic class. Just this is the internet, and likewise, no, this is not a such kind of class. This is a advanced basic class. So you learn so many things you don't know before, right? So no answers. Why? Okay, clear. Okay, no, I need to open this one again using Chrome. So I was talking about internet and the history and the growth. Okay, now here, right? So up to this level I discussed, and I have shown you something interesting about internet. Now, so who runs the internet? So no centralized management exists, and many private organizations, universities, and government agencies pay for and run a part of it, right? So how does the information travel across the internet? So data is divided up into packets, and information is carried in packets. So the delivery mechanism or the protocols that is used on the internet are referred to the TCP/IP, right? So that is how the information can be delivered within the internet. Okay, any problems up to this level? No problems, right? So how the internet works now? See, so this is really important and interesting. Here, so three concepts make the internet available. So what are those three concepts? Internet protocols, internet addressing, and client server computing. After I teach this lesson, I will ask you a really interesting question, because I know all of you, most of the you are using torrent to download films, TV series, and everything, right? So I will bind questions with the concept which you are using, right? So because I always try to align this course and give you the practical experience with your real life, because I know most of the students you are using a torrent and download so many things, right? So I will ask questions from that also. Okay, now you know three concepts we need to make the internet available. So those are the internet protocols, internet addressing, and client server computing. Now you know internet protocols, so that is a set of rules which is used to communicate. Now, internet addressing. So internet addressing means if I need to reach to your place, I should know your address, right? So without knowing your address, I have no way to reach to you, right? So your place, or if you don't know the address of the university, then you have no way to reach to this university, right? So both the sides, you should know my address, I should know your address. So in order to reach to each other's place. So I'll discuss about internet address later, right? So then client server computing. So tell me, previously I asked from you, client server, actually it as a host. So because I talked about host before, because I asked you to, if you are using a particular mobile device and you are going to access a particular web address, and then your mobile device or the mobile phone acting as a host. Now, I am asking again the same question. Now, if you are using your mobile phone or laptop, desktop, or whatever the device, and you are going to access a particular website, maybe Facebook or some other websites, maybe YouTube or the University of Pune website. So then, who's the client here? Who's the client here? Okay, one answer I got. What's that? Me. That means, tell me, me means what's that? User. That means the client means user or your device. user comes with usually device, right? So because user itself cannot access the website because you should be there, then you need to type your web address and then you can access the particular website. So then you act as you and your device acting as a client. So if you consider the concept of the device, then the your device is the client device. Then the YouTube server or the YouTube the place we host our YouTube website. So what's that? So that is a, tell me, that is a server, right? Okay, now you know what is client, what is server, and we can talk about more detail. And now internet protocol, so a set of standard rules that governs the communication between computers on a network, and I told you that one. So TCP/IP is a transmission control protocol and internet protocol. Actually, TCP/IP is not a single protocol. So the basic communication protocol that is the foundation of the internet. Other internet protocols like TCP and then HTTP, and here actually the HTTP sits on top of the TCP/IP. So this is really important. HTTP is another protocol, and this HTTP sits on top of the TCP/IP, right? So the TCP/IP is actually a base. So the TCP/IP stands for Transmission Control Protocol and Internet Protocol. So TCP/IP is actually a collection of protocols or rules that govern the way data travels from one machine to another machine or the another place across the network. So here the internet is based on TCP/IP, right? So now see how the internet works. So internet addressing is required for access a particular device on the internet. So here the each computer on the internet is identified by a unique number called IP address or the IP number, right? So an IP number is a 32-bit binary number. For convenience of writing, we break IP number into 4-bit pieces, 8-bit pieces, and convert it to a decimal within a period of between each part, right? So here you can see the binary version 00001010. So the decimal version of this portion is 10, right? So I assume you know how to convert binary to decimal. If you don't know, then you need to go through your grade 11 textbook ICT, right? Then the second portion of the binary version, right, it contains 1001011. Then it belongs to 139. Then the next part belongs to 203, and the last part belongs to 131. So then here the basically each part can take values from 0 to 255, right? So each part means this part maximum can have 0 to 255 value, right? So here you can see 10. Then this value can be varied from 0 to 255. Here you can see this part is belong to 203, and we can go up to 255, right? So that means if you convert this binary number to decimal using 2 to the power 0, 2 to the power 1, 2 to the power 3, and 2 to the power 4, 2 to the power 5, 6, 7, 8, and then you sum up all these things, then you will get 255, right? So there can be 256 and 256 unique address available. That means for these 4 portions, right? So here you can see 1, 2, 3, 4. We have 4 portions. So we have this much of unique addresses available. So each computer on the internet is called host, or host computer, or host. Maybe sometimes we call it as host computer, or the host, sometimes we call it as host. Now we are going to talk about client server architecture, right? So this is really important, and now you know who is the client, who is the server. But now we are going to go in detail with this architecture. So how the internet works. Now the computers on the internet uses a client server architecture. Here the server, each internet host can act as a server. Each internet host can act as a server. Remember this part. So let's see actually the meaning of this statement. So the machines that provide services to the other machines are servers. That means if you are going to access the university website, so then there is a place which we have actually there are separate staff, and they are maintaining these websites, and they have put this website in a particular computer, and we called this as server, computer server, right? So and your LMS is also there. So that means the machine that provides service to other machines, that means you are going to access your LMS using your computers or mobile phones. So now you are the client, and the service given by the University of Rohuna, or the whatever the university. So this concept, in this context, the server is the University of Rohuna server. Right. The server's purpose is to wait for the request and from some clients, and find the requested file or the page, and then send it back to the client. So what is the purpose of the server? Server is waiting for the request and find whatever the file or the resource they are looking for. That means the client's request, and then send back to the client the requested file or the directory. That directory means if you are going to download something, some folders, then so those folders, the location of those folders send back to the client, right? So server is waiting for your client request and fulfill their request by sending back the required information to the client. Then there are web servers, email servers, FTP servers. So web servers is a different server, and we can use for actually in order to host a particular website. And there are email servers. So we use these servers for email hosting. And then file servers, that means FTP servers, right? So file transfer servers available like Google Drive, and the email server may be Gmail servers, and the web servers, you know, so many web servers available in University of Rona. We are hosting websites inside that web server, and it is dedicated for web hosting, not the emails and other kind of things. Then client is actually the machines that are used to connect to the servers and request services from them, called as client. So you are the clients, and you are requesting a particular web page or particular service from a particular web server. Here, so this is the client computer. Here, this one, and this is the internet, right? So this cloud represent the internet. And here you can see this client computer is sending a request to the web server. That means the server computer. And the server computer waits for that request and respond with the requested file or the requested service, right? So send the service back to the client computer. Okay, right? So those are the things I need to discuss, and I will ask some interesting questions from you. So when you are using, how many students who are using torrent? Yeah, you use. So is it a client server architecture or some other architecture? Only one. Others are didn't use, right? So I think the majority of the students are using torrent to download TV series and so many things you are downloading. No, so it is yes, really. Now you are using, right? So I know you all are using. Most of the students are using torrent to download some TV series and some files and everything. So here we are not using uh, client server architecture. So that is another architecture, and you find that one. What's that architecture? Right? I'm not going to tell you. You should find that one, and next day I will ask. Right? Okay. Then what's the next thing I need to ask from you? The next thing. So again, another question I'm asking from you. So now you can see here only single client computer, right? Only single client computer, and this is a server, no problem. One single server is enough. But okay. So would you give us this? Yes, yes, I will give you. Don't worry. I will give you everything. I will give you. Okay, now I'm asking interesting question here. So you can see here one computer server and one computer client. That means client computer. And suppose this computer server contains two web pages, A and B, right? So this client computer is requesting, could you please show me the page A, web page A, and then computer will give the web page A to this client computer. And another client computer, suppose another client computer is here, and that computer is asking about, could you please show me the page B, right? So then this server computer will respond with the page B, and it is displayed here. Now tell me how this computer can determine each and every computer separately. Suppose mistakenly, if this computer is asking about page B, page A, but the server respond with the page B, and this computer is asking about page B, suppose another client computer is here, so and mistakenly computer server gives page B. So this server mixing up all the connections. What happens then? So is there any mechanism to control this one? So really interesting question. You need to think about that. How you can how computer servers can manage these things. Tell me if you know. If you know, tell me. I think most probably by IP addresses. Yeah. So acceptable answer. IP addresses. Any other answers? One more. What's that? Through the internet? Yes, through the internet. But how? I'm asking how it manages, how they can manage the connections. Suppose Now you are accessing your Facebook account and some other person accessing their Facebook account, and you all are requesting, you all are sending your request to the Facebook server, and the Facebook server mixing up all things, and this Facebook server will show different profiles to you. Sometimes is it cookies? Uh, Cookies is a different story.
Yes.
So how? I don't know whether you have heard about that. We use sessions, right? So there is a concept called sessions. By using sessions, we can manage each and every tab of. You can see here I have opened multiple tabs here. Can you see my screen? I have opened this Learn platform and some other websites, YouTube and Google's, everything, right? So these kind of things can be managed using sessions, right? So there are different session keys with respect to a particular tab of this Google Chrome. Not only Google Chrome, if you are using Firefox, if you are using Safari or any other web browser. So almost all the web browsers, they are using sessions to manage, to differentiate each and every session which you are interacting with a particular web server, right? So that is how they manage different connections. Okay, you got the idea. There is a concept called sessions. And what is the meaning of the cookies? And cookies means uh, when we are going to log in a particular website first time, then they will ask, oh, now you have come to our website and we are warmly welcome you. And when you are coming to the next time, then it's familiar. We can familiar you. Could you please put my cookies inside your web browser, right? So then that particular website send you some small set of information to keep with us, and then next time when we are logging to the same website, then they will identify that particular person has come earlier also, right? So then based on that they can show you different new informations. So that is about cookies, and right? So okay. And tomorrow also you are having a class, right? Tomorrow morning you have a class, right? Don't you know that? Tomorrow class?
FDN class.
Yeah.
Yeah, it's on the timetable. In the timetable.
It's not on the timetable. Really?
No, it's in the timetable.
Yes, you know, right?
Yeah.
Okay, then tomorrow it's better because now then I can show, because then I had my router also, then I can show you how you can improve the 4G signal also, because nowadays, now here in my office I have my router there, right? So it is in my the residence place. Then you can I'll tell you how you can improve the 4G signals and how you can measure the signal strength and everything related to that also. So that is for your life, not for the course. Okay, so then let's meet again tomorrow. What's the time? 8, right?
It's 8 o'clock in the morning.
8, right? Okay. So then anything you need to know? So I'll give you all the PDFs, right? So don't worry about, I'll give you everything. This week, tomorrow, most of the time I will give you, right? Okay. What's that? Anything you need to know? I stop when it's 10:30. No problems, isn't it? Okay, then I'm going to wind up the session, right? Okay, right. Now, okay, no problems. Clear. Okay, thank you. Thanks again. Okay, then let's meet tomorrow at the same time. I think it's 8 o'clock, maybe, right? So I'll share another link and you can join, right? So then we can discuss more detail about internet and how it works and different types of internet connections and everything. Okay, thank you. And can you explain host and server? Yes, host means yeah, you are asking really good question. So host means almost all the devices which we have been connected to the internet called as host, maybe a server, maybe a printer, maybe a desktop computer, maybe a laptop computer, everything. If we have connected a particular device to the internet or a network, right? Internet or a network, right? So those devices can be called as host, right? So then server may be a host computer. Then the printer is a host, and other network connected devices can be a host, maybe desktop computer, maybe your mobile phone. So those almost all the devices, if you have connected those devices to the internet or a particular network, then those devices can be called as host, right? All the devices can be called as host. So the difference is the server also can be a host, right? But the client means if we are requesting a particular information from a computer server, then the requested person or the requested device is called as a client, right? So the service provider can be called as server, but client and server, all the things can be considered as host devices, host computers. Is it okay? You got the idea? You have asked a really good question. Dulika, right? Is it okay, Dulika? Right? Any questions? Okay. Yes, another question. What's that? Yes, sir. If the server will be down, can't we work or get any service from it? How does it happens? Because the servers are also the computers which has been connected to the 24 hours power connection and the internet connection, and there may be some troubles can be happen. And for that, have you ever experienced the breakdown of the Facebook? I think you should. It happened several times. I think 2 or 3 times, and massively happens in recently. And right. So there is a mechanism load balancing, right? So nowadays, in our fuelpass.gov.lk, right? So the minister, the Kanchana Vijayasekare's website, right? That means the government website which is used to distribute the fuel passes. So here, the first time initially they didn't implement actually the large capacity of load balancing technique. So that's why almost all the people are going to register with that website, and then so almost all the people cannot register at once, and there may be some difficulties, and now they have solved those difficulties, I think. And another thing is scholarship. When you are going to look up your scholarship examination result when the result is released, and at the same time almost all the people are trying to look up their result. So then what happens then, if they didn't manage load balancing, then the server will go down. For that, the mechanism is load balancing. Then the load will be distributed to a particular duplicated servers, and the same information is available on multiple servers, and by considering the load, they distribute those requests to a different servers, right? So now Facebook is working on that scenario, right? So they have different servers: Facebook Asia, Facebook Europe, and Facebook Africa, and different servers available, right? So we call this as distributed system, and that is not actually in your subject or in your modules. So that is the advanced concept in computer networks and communication. But for your knowledge, so basically what we have done here, we balance load and we distribute the load to a multiple servers. Is it okay? That's why very rare situations Facebook and the public and popular websites goes down. Really very rarely it happens. Okay. Okay. Then any questions? Anything you need to know? Nothing, right? So now then I'm going to wind up. Okay, thank you. Then next day we can meet again. I'm going to stop share and I'll give you the recordings and the notes also. Don't worry. Okay, thank you. Thanks again.
Thank you, sir.
Okay, thank you again.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, thanks you.